All right, so I'm gonna go through, let's see here. I'm gonna go through some of the problems in homework number 3 and homework number 4 because all of the test questions are gonna come from your two homeworks. And then show you some ways that you can work through some of these problems quicker using your calculator or also a website called Desmos. The first group of problems has to do with calculations involving complex numbers. So in homework number 3, the first number, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 10 problems out of 33, so about a third of the problems in homework number 3 just have to do with you calculating things with the complex letter I. And all of those problems can be worked in your calculator. Your calculator has an I button right above the decimal point. So if you look at the bottom of your calculator, you've got the on button, you've got the 0 button, you've got the decimal point button, the negative button, and then the enter button. Now, right above the decimal point, there's an I. And to get to it, you need to hit the second function button. The only problem with using this is sometimes your answer, or the calculator will give you back a really funky answer that really means 0. So for the problems that ask you to do like 2 plus the square root of -4 times 3 minus the square root of -16, you need to put your calculator in a different mode. Right now, if you entered this into your calculator would say, it would give you an error because this is a non-real answer. So I'm going to put my calculator in A plus BI mode. Right now, your calculator is probably in real mode. So if you hit the mode button on your calculator and scroll down the screen, you probably see that it's in real mode. And we want to switch it to A plus BI mode. And that will allow your calculator to deal with this square root -4 and change it to an I. And then we can type this into the calculator and it will do that entire calculation for us and switch it to I's for us as well. So if I put my calculator in A plus BI mode, then I can type this entire thing in. 2 plus the square root of -4 times 3 minus the square root of -16 and hit enter, and my calculator says 14 minus 2i. I didn't have to convert either of those to i's. I didn't have to do the foiling or the simplifying. The calculator did the whole thing for me. And the type of problem that is usually most complicated for people are the division problems. When it tells you to divide 2 minus, well, let me not do 2. 2 minus I divided by 1 plus 3i. If you read it in the book or if you went through the Help Me Solve It, it would tell you to multiply by the conjugate and then simplify the top and the bottom and then separate it into two pieces. When really your calculator can do this for you as well. The trick is, though, you have to make sure you enter the numerator and the denominator in separate sets of parentheses. Because 2 minus I is the entire numerator and needs to be enclosed by parentheses. 1 plus 3i is the entire denominator. It needs to be enclosed by parentheses. And again, we can use the I button to type that entire thing into the calculator. So I am typing this into the calculator with the I button, and I am getting decimals, and most likely MyLabs Plus is not going to want decimal answers. So on your calculator, there's a way to change these back to fractions. So with this on my screen right here, I'm going to go to Math, the Math button, which is 2 buttons below your second function button, and I'm going to choose option number 1, which has got this little triangle, and then it says FRAC, which means change this to a fraction. I'm going to choose that, and it's going to change and hit enter, and you may have to hit enter twice, and it will change it to -1/10 minus 7/10 I. And that is most likely the answer that MyLabs Plus is going to want, is the fractions. And it will even do the powers of I. So if you're asked to simplify I to the 43rd, and these are the ones that sometimes the calculator gives you back a really weird answer. And the trick is you really have to understand what the calculator is telling you. On my calculator, if I type in I to the 43rd power, what it tells me back is 3e -13 minus I. That is not the answer. This piece right here means 0. E to the -13 power, this is scientific notation that means 13 zeros behind the decimal point and then a 3. So 0.0000000000, 13 zeros and then a 3 minus I. Anytime you see E negative and then a big number, ignore that whole thing. It's just 0. So really the answer here is just -I. I don't know why the calculator sometimes does this with the I function. It's something we just have to deal with if we want to be able to use that I button. It mostly just happens with the powers. It doesn't come up with the addition, the subtraction, the multiplication, the division, just the powers. So as long as we know about that and we're able to recognize it, then we can just ignore it and throw it away. And then we can keep using it. So all of those problems dealing with computations with the I, all of them can be done on the calculator and save you a bunch of time on your test. Just type them in the calculator, have your calculator in A+BI mode, and use your I button. The A+BI mode allows you to type in square roots of negatives, and it will convert them for you. And we'll have all those answers very quickly. The next group of questions in the homework number 3 has to do with solving quadratic equations, which is section 3.2. And there are 4 different ways to solve quadratic equations. Some of the problems in the homework asked you to solve it a specific way, but then all they do is they give you an answer box. So there's no way for them to check how you solved it. So if you see a question on the test that tells you to solve it a specific way, you can ignore it and you can solve it any way you want, because there's only going to be an answer box. And no matter which way you solve it, you're going to get the same answer. So there is, and then it goes into section 3. Okay, so everything in section 2 is solving quadratic equations. So the first way we can solve is by factoring. So if you're good at factoring, the whole idea behind factoring is that if you can get your quadratic factored, the zero product principle says that if a times b equals 0, then either a equals 0 or b equals 0. Now, that doesn't look exactly like what a quadratic or a factored quadratic looks like. This is just saying if any two things multiply to make 0, then we can separate them. So when we factor, what we're doing is we're separating our quadratic into a product of two linear factors. So the a and the b are going to be two linear factors. And solving by factoring only works if you have it set equal to 0. This is called the zero product rule. Some people do not enjoy factoring and are not good at factoring. And factoring does not always work. Not every quadratic can be factored. So if you don't immediately see how to factor something, I would not try factoring. I would not waste a whole lot of time trying to factor. But a good example of when you can factor is something that is maybe already factored. So if something is given to you already factored, then definitely I would use this zero product principle. If two things multiply to make 0, that means one of them is 0. So the zero product principle says that I can separate these into two separate equations and set them equal to 0 separately. And now it's just solving two linear equations to get my two answers. So we use our opposite operations to get the x all by itself, and we get x equals 1/2 and x equals -3/5. So to start one of these problems from scratch, we would usually have to do the factoring all by ourselves. So if we were told that that we wanted to solve x squared minus 5x equals 6, if you didn't immediately see how to factor that, you probably don't want to waste 5 minutes trying to figure out how to factor it, because there are other ways to solve quadratic equations that don't take as long if you're not good at factoring. I will go through this one with factoring, but then I'm going to move on to a different method. With factoring only works if it's equal to 0. So you would have to move the 6 over. So that's a positive 6, so to move it over, I'm going to subtract it over. And now that it's equal to 0, I want this side factored. So I'm looking for two numbers that multiply to make -6 and add to make -5. And that's going to be -6 and +1. And now this says x minus 6 times x plus 1 equals 0. So if those two things multiply to make 0, that means one of them has to equal 0. Either x minus 6 equals 0 or x plus 1 equals 0. And then we can solve them individually. So x either equals 6 or -1. So I don't suggest the factoring method unless you are good at factoring and you're comfortable with factoring. Even then, you've got to understand that not every quadratic can be solved by factoring. Only do it if you are good at it and you can immediately recognize that it can be factored. And factoring can only be done if it's set to 0. So your first step with factoring is to always move everything over to one side of the equation. The second method for solving is called the square root method. And the square root method can only be done if there's only one x in the whole entire problem. So again, this method can't always be used. We can't always use the factoring method. We can't always use the square root method. So an example of one that we might be able to use square root method, and it's called the square root method because at some point we're going to be using a square root to cancel a square. If there's only one x in the whole entire problem, we're going to be using opposite operations to get the x by itself. So if we had x squared plus 9 equals 16. It's a quadratic equation because we see the square, but we can use the square root method because I only see one x in the whole entire problem, which means I can just use opposite operations to get the x all by itself. I'm just going to start moving things over to the right hand side away from the x one at a time until I have x all by itself, and then I'll have my equation solved for x. So I'm going to start by subtracting my 9 over. I get x squared equals 7. And then now to get the x by itself here when it has a square, I'm going to do a square root. That will cancel off the square. Anytime you use a square root to cancel a square, you have to put a plus or minus in front of your answer. So this one still ends up, just like with our factoring, it still ends up with two answers, a positive and negative square root 7. There is a plus minus button in MyLabs Plus, so you can type this in as plus minus square root 7, or you can separate it and say the answers are positive radical 7 and negative radical 7. So you could type it in either way. So another example of one that we could solve with the square root method. Two times x minus 3 squared minus 1 equals 9. So it's a quadratic because we see the square. One of you has got terrible feedback coming out of your speakers. It's a quadratic because we see the square. And we can use the square root method because I only see one x in the whole entire problem. So all I'm going to do is I'm going to use my opposite operations to get the x all by itself. There is a lot of stuff over here that has to get moved. So to decide what to move first, anytime you are solving, you do order of operations backwards. So normally order of operations is, please excuse my dear Aunt Sally. Normally we do parentheses and then exponents and then multiplication and division and then addition and subtraction. When we solve, we do this in reverse. We start with addition and subtraction, and then we take care of multiplication, division, then we do exponents, then we do parentheses. So when we solve, we start here. We start with addition and subtraction. So to solve this, I need to start with the subtracting 1 here. I need to move that over. So I get 2 times x minus 3 squared equals 10. And then we'll take care of multiplication division. So we'll divide the 2 over. X minus 3 squared equals 5. Then we'll take care of exponents. To get rid of the square, we will square root. And remember, anytime you use a square root to cancel a square, you've got to put a plus or minus on the number side. Technically, there were still parentheses there, but since that's the only operation left, we can deal with what's in the parentheses. We've got to add the 3 over. Now, those can't combine because one number is inside the square root and one number is outside the square root. So we just write them next to each other. We say x is 3 plus or minus square root 5. So this one started off looking a little bit different, but it's another example of where we can use the square root method. What these two had in common was that it started with only one x in the problem. If there's only one x in the problem, we just use opposite operations to isolate the x. And at some point, we're going to use a square root to cancel the square. Anytime you use a square root to cancel a square, you've got to do the plus or minus on the number side. Plus or minus. Because almost all of these quadratic equations have 2 answers.
So if you had several x's in the equation, you could combine them all to make it x to the 5th, and it would still be 1x in the problem.
Say that one more time.
If, like, for instance, you started that with an x squared, didn't you?
Yes.
So if you had multiple x's, if you had 5 x's in your problem, you could combine all the x's to make x to the 5th if they weren't in parentheses with another, like minus a number or something.
Right.
If they weren't like that, you could combine them all to make 1x.
If they were being multiplied, then we can combine them. If they were being added and subtracted, then we wouldn't necessarily be allowed to combine them unless they were like terms. So
let's see, x minus 3. So, I mean, is there a way that you can think of off the top of your head to take that x minus 3 and sort of multiply it by something that would keep the equation balanced out, or keep it the same as it was, but take that, it would take that minus 3 away from your variable, so you could combine x.
Not with the squared on the outside. The square acts as like glue, and the square has to be addressed before you can get to the insides.
Okay, so you could, but after you square it, you'll have.
After you square it, then you can start monkeying with the stuff on the insides.
What if it doesn't have a square, but it's in parentheses?
Then that usually means that there is something on the outside that needs to be distributed, like the 2 that we had outside.
Okay. Do continue.
Okay. You're fine. Feel free to stop me anytime.
No, I hope. Okay, go ahead.
The third method, I do not suggest you use on the test at all, because it takes a long time. And since we already have 3 other methods that you could possibly use, You really don't need this method. The third method is completing the square. I'm going to show you one example of this, and I'm going to tell you do not use this on the test. We're trying to cut down the amount of time that we take on the test, and all this is going to do is going to add time to your test. The point of completing the square is to take a problem that has multiple x's in it and turn it into a problem that we can use the square root method on. So this is turn any quadratic equation into one that the square root method will work. Some of this looks like magic. There is reasoning behind it. But if I were to ask you to complete the square, solve by completing the square, the first step is we're going to try to make a polynomial or a quadratic that is a perfect square. And the one that we're going to try is x squared plus 6x minus 15 equals 0. So this is not a perfect square. A perfect square is one that you can factor to be x minus something squared. And if it's x minus a number squared, that means it's x minus something times x minus something. That's what squared means, is you're multiplying that same thing twice. Now if we FOIL that out, it's x squared minus xa minus xa plus a squared. So x squared minus 2, I'm actually going to put the a in the front because they're numbers, x plus a squared. So what we're looking for here is to have a perfect square in the back so that the middle number is double of the non-square of that number. So if I were to cut my middle number in half and then square it, so if you take this number and cut it in half, that takes the 2 off, and then square it, and I'll get the back number. So this 15 here, that doesn't make this a perfect square. So I always move the constant over to the other side. The constant that's in there now does not make this thing a perfect square. We need a different constant in there to make that a perfect square. And the constant that we need is always going to be half of this number squared. So I'm going to take that 6 and I'm going to cut it in half and then square it. That is the magic number that will always turn this into a perfect square. So 6 divided by 2 is 3. 3 squared is 9. So I can add 9 right here as long as I also add 9 over here. We can do it as long as we do it to both sides of the equation. So this is x squared plus 6x plus 9 equals 24. So it's still the exact same equation that I started with. I just moved the 15 to the other side and I added 9 to both sides. Now this is a perfect square. This factors to be just one linear expression squared. It factors to be x plus 3 squared. equals 24. And now that can be solved with the square root method, because that only has one x in the whole entire equation. So to continue solving, all we have to do is square root. And remember, when you do a square root, you put plus or minus in front. And then the last step to get x all by itself is going to be subtract the 3 over. And we can't combine it with the 24 because 3 is going to be outside the square root, 24 is inside the square root, so I just stick it in the front. There is going to be one step of simplifying here because square root 24 will simplify. We can simplify square root 24 if there's a way that we can break up 24 into a piece that's a perfect square. So we want to think of a way where we can split up 24, and 24 can be thought of as 4 times 6. And 4 is a perfect square. The square root of 4 is 2. So we can rewrite this as 2 root 6. So x is negative 3 plus or minus 2 root 6. So that took a long time. And if you try to do complete the square in your test, it's going to take a long time. And this was actually one of the easier problems. So if you get a much harder quadratic equation to solve, it's going to take even longer. I do not suggest you do complete the square on your test. There's our fourth method. Our fourth method can be used on every single problem, whether it can be factored or not, whether it has just one x in it or whether it has two x's in it, does not matter. The quadratic formula can be used on every single quadratic equation. So the basic setup for a quadratic equation is ax squared plus bx plus c equals 0. The a, the b, and the c are going to just be numbers. And if we can identify what those numbers are, the solutions for this quadratic equation, we can get by using the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a fairly complex formula, but it works every single time on every single quadratic equation. So all we have to do is make sure we have our quadratic equation set to 0, have everything else on the one side of the equation, identify your a, your b, your c, and then plug them in and simplify. So unless you can obviously see how to factor, or if there's only one x in the problem and you can very quickly solve with the square root method, quadratic formula is how I encourage you to solve your quadratic, at least your more difficult quadratic equations on your tests. Oops, sorry. So here's an example of one. I have no idea if it factors. There's two x's in the problem, so I definitely can't do square root method. I don't even want to attempt to complete the square. It's going to just add too much time onto my test and just waste time from other problems. So I'm just going to jump straight into the quadratic formula. So the first step to start quadratic formula is I need it set equal to 0. I need all of the terms on the same side. So I'm going to take this positive 2x and I'm going to subtract it over. And I want my terms in order. I want my x squared term first, my x term second, and my constant last. So I'm going to squeeze this guy here in the middle because the A, the B, and the C, which one I assign to what is important. So the 3x squared is going to be first, the minus 2x is second, the plus 5 is last. So I can identify my A, B, C appropriately. So looking at this, the A is 3. The A always comes from your x squared piece. The B is going to be negative 2. You always use the sign in front as well. And the C is 5. And all I have to do is plug those 3 values into my quadratic formula and simplify, and I'll have the solutions for my quadratic equation. So the formula is x equals negative b. B is already negative, so I'm going to have a double negative, and in just a minute I'm going to simplify that. Plus or minus the square root of b squared minus 4ac all over 2a. Now be really careful in this formula. No matter what the b value is, when you square it, it's going to come out positive. If b is positive, when you square it, it should come out positive. If b is negative, when you square it, it should come out positive. That value, when you plug it in your calculator and square it, put parentheses around it. Anytime you plug a negative number into your calculator, you should put parentheses around it. I see a lot of people get this problem wrong just because they would type this negative number in without parentheses, and when they square it, their calculator says the answer is negative, which is not correct. And now I'm just going to start simplifying this. So I've got negative 2, that's actually positive 2. Negative 2 squared is positive 4. And then 4 times 3 times 5 is 60. And then 2 times 3 is 6. And then inside the square root, we can subtract. 4 minus 60 is negative 56. A negative inside of a square root is going to come out as an I. Now, square root of 56, we've got to simplify that. Don't simplify the 2 over 6 yet. Because of the addition, the plus minus there, we can only simplify that 6 in the bottom if we can simplify from everything. So technically there are 3 pieces here. This piece, and this piece. And if we're going to simplify, we have to simplify from all 3 of them. So we need to simplify the square root 56. There is a way to simplify square roots in your calculator. If you ever want to simplify a square root, what you can do is in your calculator under y equals, you can take that number that's underneath the square root and say 56 divided by x squared. Because technically what we're looking for is to see if that number has any perfect square factors. We're seeing if we can split it apart into any perfect squares. So I'm going to type in 56 divided by x squared, and I'm going to go to the table, and I'm going to look down the table and see if I see any whole number pairs between my x column and my y1 column starting at 2. We don't need any negatives. And we don't need 1 in 56. That's already technically what we have right now. And keep going until your y1 gets below 2. Once this number goes below 2, we're done. We can't do it anymore. So we're looking for a whole number pair here. We don't want decimals. So in my y equals, I'm putting in 56 divided by x squared. I'm going to my table, and I'm scrolling down. And as I scroll down, I see the pair 2 and 14. I'm going to scroll down even further, because if I can find a bigger pair, that would be better. But as I go farther down, my y's start getting into the decimals, and I'm done. So the only pair I see is 2 and 14. And what that means is that square root 56 can be simplified to 2 square root 14. So this always simplifies to x square root y. Whatever you see in the x column is what comes out. Whatever you see in the y column is what stays in. So that's a fast way to simplify square roots, especially the bigger ones. Some of the littler ones you might be able to recognize how to do them really quickly without the calculator. So we can simplify that square root 56 as 2 square root 14. So this is 2 plus or minus 2i square root 14 all over 6. And now I see that all three pieces have something in common. They all have a factor of 2. So I can take a factor of 2 out of all of them. And if I do that, I'm left with 1 plus or minus I root 14 over 3. And it can't get any simpler than that. That's the best we can do. 1 plus or minus I root 14 over 3. So the hardest part here, I think, was the simplifying. The easiest part was just getting everything plugged in. We always want to take negatives inside of the square roots and pull them out as the i's. Now that we know about complex numbers, that is always going to be expected, that the negatives come out as i's. You are always expected to simplify those square roots. If you do not have a lot of experience with it, then go through this process. Just take the number under your square root, and in your y equals, say divided by x squared, and look for a whole number pair in your x and y1 column. And that is a quick way to do that. So on your test, I really think quadratic formula is the way to go. Unless you are good at factoring, or you can easily see the way to factor it, or if you recognize it as just having one x in the problem and you can quickly do the square root method. There may be a couple of questions on the test asking you about the discriminant. And the discriminant has to do with a piece of the quadratic formula. The discriminant is b squared minus 4ac. And if you look back up here, b squared minus 4ac was the piece inside of the square root. The value of that piece is going to decide what type of answers you're going to get. Whether the answers are going to be complex, or whether they're going to be real, whether you're going to get 2 answers or whether you're just going to get 1 answer, because that is the piece that's under the square root. So if you just find the value for b squared minus 4ac, if that value is negative, so less than 0, that value is under the square root. If you have a negative number under the square root, that's when we get i's. I's are complex numbers. So if your discriminant is negative, you're going to have 2 complex solutions. If b squared minus 4ac is equal to 0, well, look back up here and see what would happen. If b squared minus 4ac is equal 0, this whole plus minus section is going to be gone. This whole plus minus section right here is going to be gone, and all you'll be left with is negative b over 2a. Negative b over 2a is just one real answer. the whole plus minus part is gone. So you don't have two answers anymore. You just have one real answer, or one real solution. If b squared minus 4ac is positive, then you have a positive number under your square root, which means you're adding or subtracting a positive number, and you're going to have two real solutions. So just knowing the value under the square root tells you all about what kind of answers the quadratic equation is going to have. And then the last part of section 2 is the equations that are quadratic in form. So for these equations, the format looks very similar to a quadratic equation. And the format is that it's a trinomial. So we have a times some function squared plus b times the same function plus c equals 0. Now that function could be pretty much anything, and we see it there twice. There are three terms. We've got those two matching functions where one of them is squared and one of them is not. Examples of what this might look like. X to the 6th plus 5x cubed plus 4 equals 0. So you might be saying, well, it says it's going to be, one's going to be squared and one's not. Well, this is just telling me the pattern. There could really be any power there. The pattern is that the first one is always going to be double the second one. And we do see that here. The first one is double the second one. So notice that the second one is not doubled. The second one is the original function. So the original function is x cubed. So what we do, and we actually use a u for this, is we're going to do a substitution so that this actually looks like a quadratic equation. I'm going to say u is x cubed. If that's true, and I know that 6 is double 3, that means u squared is going to be x to the 6th. And I can rewrite this entire equation to look like a quadratic with the u's. That's u squared. That's my regular u. And now it looks like a quadratic. And I can solve it like we've been solving all of our quadratics. The only difference is now I'm solving it for u. This one I easily recognize how to factor, and with almost all of these equations quadratic in form, they do easily factor. This part is difficult enough. They don't also want to make the actual solving part difficult. So look for the solving to be pretty easy for these. So with solving by factoring, if we can get it factored, then we can separate. So I get u equals -4 and -1. That wasn't our main objective from the get-go, though. Our objective was to solve for x. But we've almost got it. I've got u is -4 and -1. So now we need to go back to the substitution we did. U is x cubed. So I'm going to replace u with x cubed. So x cubed is -4 and -1. And I've got one more step to do. So if I know what x cubed is, I need to figure out how to solve for x. So if a square root will cancel off a square, I'm going to use a cubed root to cancel off a cube. So I'm going to take the cubed root for each of these numbers. So x is the cubed root of -4, which doesn't simplify nicely. We're just going to leave it like that. The cubed root of -1, if you type that in your calculator, the answer is -1. So for these equations quadratic in form, they follow this format where there's 3 terms and the first variable piece is always double the second variable piece. And we're going to let u be equal to the one that's not doubled. And we're going to rewrite the equation with the u's so that it actually looks like a quadratic. And then we're going to solve it out just like a quadratic and solve for the u. And once we have our answers for u, we're then going to go back to what we said u was equal to and plug the x back in, and then just do one more step to solve for the x. I'm going to do one more of these real quick, and then I'm going to stop this video because it's getting kind of long already. I already have a video on our Moodle page for section 3. Section 3 is not very long. It just has to do with the different characteristics of a parabola, where the vertex is, where the axis of symmetry is, the maximum or minimum value. So when I post this video, I will repost a link for that video, and then I can do another video tomorrow night for section 4 and section 5, just because this one's already starting to get too long. We're right at about an hour right now. But let me do another one of these equations quadratic in form, because I know these can be really tricky. So let's do x minus 3 root x minus 4 equals 0. X minus 3 root x minus 4 equals 0. So one thing that you need to know for this problem to recognize it as an equation that's quadratic in form, first of all, we see the 3 terms, which are typical with quadratic equations. But another thing that you need to know is that there is a power associated with square roots, and a square root is a power of a half. And my x in the front doesn't have a power written, which means it's a power of 1. So this does follow the format that we described, where one power is double the other power. It's 3 terms, and one power is double the other power. So the first one is the power that's doubled, and that middle one is the power that's not doubled. And remember, we're going to let u be the power that's not doubled. And that's going to make u squared the power that is doubled. And we're going to rewrite this equation with the u's. So this is going to be u squared minus 3u minus 4 equals 0. And that factors, that's u minus 4, u plus 1 equals 0. So either u minus 4 equals 0 or u plus 1 equals 0, which means u equals 4 or -1. And we're almost done. These are not our answers. We have to go back to what u was equal to in terms of x. So instead of u, we've got one more step. We've got to turn this back into an x problem. Oops. If I know that u is 4 and -1, and u is x to the half, or square root x, this means that square root x is 4 and -1. And to solve that equation, remember that squares and square roots are opposites of each other. So to solve for x, I need to square everything. So x is either equal to 16 or -1 squared is +1. With this problem, you need to be very, very careful. Anytime you are working with a problem that has square roots in it, and you may have figured this out by now from section 4 and section 5, problems with square roots, you have to check your answer, because sometimes you will get answers that don't really work. So we need to plug these numbers in and make sure that they really work. So I'm going to plug 16 back into the original problem and see if it really works. So 16 minus 3 root 16 minus 4 equals 0. Well, the square root of 16 is 4. 3 times 4 is 12. 16 minus 12 is 4. 4 minus 4 is 0. Yep, 16 works. And let's check 1. If I plug 1 in, 1 minus 3 radical 1 minus 4, does that equal 0? Well, the square root of 1 is 1. 3 times 1 is 3. 1 minus 3 is -2. -2 minus 4 is -6. No, -6 is not 0. So this one doesn't work. So really only 16 works. X equals 16. So that one was a little tricky. These ones with the powers I think are a little bit easier. And equations quadratic in form in general are kind of tricky. So just kind of to wrap this up, section 1, the complex numbers, do them all on your calculator. Do all the complex numbers on your calculator. All the calculations with complex numbers, use the I button on your calculator. Solving quadratic equations, if you can immediately see how it's going to factor, then use factoring if you're good at factoring. If there's only one x in the problem, then you can use the square root method. Do not use complete the square, no matter what the instructions say. Don't use complete the square. Your safest bet is to use the quadratic formula. Just be really careful when you're simplifying. The b squared should always come out positive. This entire expression is under the square root, and the whole thing is over 2a. So those are two common mistakes, actually 3 common mistakes that I see people make with quadratic formula. And when simplifying, if you have a hard time simplifying those square roots, you can always use this, this method that I showed you here in the calculator to simplify square roots. The discriminant can tell you about what kind of solutions the quadratic is going to have. And then equations quadratic in form, we do this quick little substitution for the middle term and solve it like a quadratic, and then swap back out at the end and solve for x. And there's 2 examples there. And then I'll repost the video for section 3, and then tomorrow night at the same time I'll do section 4 and section 5. You're welcome to come and watch live again, or again I will post the recording of it so you can watch it at your own time, and that's perfectly fine. So I hope it helped at least a little bit. Y'all have a great night, and I'm going to try to do this again for each test from here on out. And looking back at test number 1 grades, I wish I had done it for test number 1. But just like you guys, we live and we learn and we move on, and we try to just learn from our mistakes. So please contact me if you need help. I am very happy to help with whatever you need. You just need to let me know that you need help. So have a good night, and hopefully I will see you all soon.